Okay, good afternoon, Professor. My name is Stephen Qualina. My partner's name is Adrian Ichane, and we're going to be talking about the past, present, and future implications of rubber erasers. Before I go any further, I need to mention that this first half of the presentation is going to have to be split up into several smaller videos, so you'll probably notice transitions between every slide due to a storage problem with my phone. So, starting off, the erasing properties of rubber were discovered in 1770 by either Joseph Priestley or Edward Nairn. It is not clear which of these two gentlemen discovered it, but we do know it was an accidental discovery when one of these men went to erase designs they had on an engineering product, and they decided to use a piece of rubber, and it worked out pretty well. So the gentleman then proceeded to mass produce and sell his product in 1772. So, these first erasers were originally made from pure latex, harvested from a Hevea brasiliensis tree, also more commonly known as the rubber tree. There are more than 20,000 different plant species known to man that produce latex sap. So, latex taken from a tree can be treated with acetic acid to aid coagulation and turn into a solid. This would take place after the latex was placed in a slab in the sunlight to evaporate any water within the mixture, as well as filtered to have any solids removed for a more pure product. So there's no negative impact on the environment when this practice is done sustainably. However, it depends on how you grow the tree and whether you harvest it properly or not. If you were to take too much latex sap from the tree, supposedly 18 ounces or more, you will kill the tree. The average tree can only produce 10 ounces per harvest, and it would take at least 6 years for the tree to mature in the first place. So these erasers were 100% biodegradable, and the downsides were they were unable to be produced in large numbers, again, 10 ounces per tree and that's after the 6-year growing period. And these erasers were highly prone to temperature change. In the cold, they would become very brittle and more like a rock than a piece of rubber. And in the hot, they would be very sticky and smelly and unable to erase anything. So, the first major advance in eraser technology following the discovery of latex erasers was the process of vulcanization. Vulcanization was invented by Charles Goodyear in 1839. This process involves mixing powdered rubber with sulfur. Now, it is important to note for future reference that you do not need to powder synthetic rubbers, which I'll get into more in the future of the slides. So, once you have powdered rubber, the mixture is heated from 140 to 180 degrees Celsius inside a mechanical or industrial furnace known as an autoclave. Over a period of time, roughly an hour to 2 hours, you would mix in sulfur with the rubber, and it chemically bonds the rubber material and makes it far more durable to temperature and makes it last much longer when used. One more thing to note, it is also no longer biodegradable if it becomes vulcanized. Over time, the demand for erasers steadily rose as more and more people began to learn how to write. So, the only way to produce more erasers was abandon latex and figure out how to make a synthetic form of rubber. In 1909, Fritz Hoffmann invented what is known as polyisoprene, also called methyl isoprene. So methyl isoprene is created by polymerizing the separate compounds methyl and butadiene in the presence of a Ziegler-Natta catalyst. So the pros over latex are it could be produced in large quantities and is available for use by people allergic to latex. However, the cons are it is very difficult to obtain the chemicals through the process of polymerization, and it produced a weaker product. The material was not very good at erasing pencil marks, so eventually over time it became used in other products such as wiring, coatings, and today most commonly latex-free condoms. In the modern day, most erasers are primarily made out of a synthetic rubber called styrene butadiene rubbers. Compared to old rubbers, it was far more efficient, can also be vulcanized for further enhancement, unlike polyisoprene, can be produced in bulk much easier, can be produced in much less time, but the downsides are it takes a tremendous amount of energy input, which I'll discuss in a little bit, and takes much longer than vulcanized rubber to decompose in the natural world. So it means it could take anywhere from 80 to 200 years, depending on the size of the eraser marks. It is very difficult to tell, given that no one has actually observed small eraser shavings in a landfill environment. So in short, the production of styrene butadiene rubber is very similar to the production process of refined oils used in cars, trains, and planes. So the very first process you'd want to do is fractional distillation, in which petroleum would be heated into a gas state, and you would have thermal and chemical energy waste from this process that would leak out into the environment. It would pollute the air by releasing multiple chemicals and polluting the water. So after the oil is refined during this process, it would be mixed with sulfur and then moved on to a catalytic cracking process, in which case you would get the two chemicals, butadiene and styrene, in a liquid and gas form, and you'd want to combine these two to get what is known as styrene butadiene, and you can either stabilize it or you can vulcanize it from that point on. So, in more detail, this is a diagram of how to fractionally distill any sort of material, specifically petroleum in this case. So, what you would do is place petroleum in this flask here. Of course, not a flask, because in an oil refinery, it would not be a flask. It'd be a large basin containing oil. This is just on a much smaller scale. But the idea is you would heat petroleum in this flask up to 315 or 370 degrees Celsius. The chemicals inside of this a basin or flask would go into the tower up here and collect at different tiers. So the chemicals in the petroleum will each have a different boiling point, typically by at least 40 degrees Celsius. On the bottom tiers, you would have things used for very, very crude oils, such as that found in trains or freight ships. Whereas at the top, you would find things used in household chemicals or even basic car gasoline. And harmful chemicals are released into the atmosphere if they have too little of a boiling point. So this includes ethyl benzene, xylene, benzene, and toluene. Any excess water in this process would be carried out and then dumped into a river nearby, which obviously is not good for the animals in said ecosystem. And then from this process, you would move on and take the excess material that hasn't been boiled in this tower and put it in a much more complicated catalytic cracking process. So to keep this very simple, you would insert the oil that has been distilled in this little area here. You would pressurize it using steam and air from over here. You would have a catalyst of natrium, also known as sodium, in a pipe around here, and then it connects to a distillation column, in which case you would get more refined oils and products, or various other chemicals, in this case, chemicals used to make styrene butadiene rubber. Now, during this process, more excess chemicals will exit through other pipes, and this point right here, the flue gas is representing the various chemicals that are not needed for the other materials such as gas, rubber, or other plastic products. In a real life example, the flue gas chamber would most likely be the very top of an oil refinery's tower. And that concludes the first half of this presentation. Adrian will go into more details about the environmental impact of this process.
So the majority of the pollution associated with erasers is largely due to the oil refineries used to extract the crude oils and the factories that produce them, which both burn tons of fossil fuels and uses large amounts of water. So another version of the eraser is the vinyl eraser, which adds more impact to the environment with the use of PVC. The packaging of vinyl erasers also uses sleeves, which adds more production and waste. The synthetic erasers, however, are stamped and screen printed, reducing the amount of waste and production. The recyclability of synthetic erasers are easier to reuse and can be recycled to be used for future batches. Both synthetic and vinyl are non-biodegradable, however, and are hard to recycle due to their size, so they're often end up in landfills or just lying around. So as for the production, both the vinyl and synthetic rubber eraser have similar production methods and both use large amounts of fossil fuels and water, from its transportation to some cooling methods to some heating methods. Vinyl erasers, however, are made from PVC, which not only harms the user, but also the environment by releasing unnecessary amounts of carbon. So as for the waste of synthetic rubber, large amount of energy is used, such as chemical energy, thermal energy, and kinetic energy. And as for airborne waste, it consists of 40% of the waste in total. So petroleum is used for the transportation of raw materials from place to place, the product itself from shipment. Natural gas and coal is used for the extraction of sulfur, the fractional distillation of crude oil, the creation of the synthetic rubber itself, and the eraser vulcanization process. So large amounts of greenhouse gases are released from these oil refineries and transportation, which releases smoke, sulfur oxides, and the smell into the air. Water waste consists of the other 40% and is used for mainly oil extraction and the cooling down process from heating the erasers. Also, some oils might be spilled into the water, which also contaminates the oceans. And then the rest is solid waste and radiation, consists of the other 20%. Solid waste consists of some waste from minings, drilling waste, eraser dust that could be released into the air, which is also toxic and radioactive. So the things we could do now is we could reduce, reuse, and recycle. We can reduce the amount of erasers we purchase. We can also try to be responsible and not try to lose any erasers. I know I'm guilty. And for synthetic erasers, its shavings can also be formed into a ball by little bits of water and can be reused as an eraser itself. Also, having dedicated recycling communities to filter out erasers or given to donations that will eventually end up in landfills and reuse them to make new erasers. And some companies are already doing this and using recycled erasers for new erasers. So as for the future of erasers, some companies are already producing plastic erasers without PVC, which reduces the waste done to the environment. But is it cost efficient? But they still use paper sleeves wrapped with plastic coating, which also adds to the waste and production, as seen in the picture. But if companies were to just screen print their information onto erasers itself by using natural or recyclable ink, it would change the amount of waste and production, so even cheaper for companies to produce. Using or developing material that is not only abundantly available, but also has the properties of an eraser that is easy to produce and that can be biodegradable is also one option. Also, modifying latex trees so they can produce more efficiently, so we could go back to using natural rubber erasers instead of synthetic plastic erasers. That is our presentation. Alright, thank you for watching. Thank you for listening. This is Adrian and Chana and my partner, Steven. Thank you.